As we talk about writing linear equations, we need to remember, that there were several forms of a linear equation that we worked with in the past. We've worked with slope-intercept, we've worked with point-slope, and we've also worked with standard form. We're going to be focusing on this section with just the point-slope form and then the slope-intercept form. And if you don't recall, the point-slope form looks something along the lines of y minus y1 equals m times x minus x1. And then the slope-intercept form was y equals mx plus b. Most people are more familiar with the slope-intercept form, one, because it's easier to graph, and two, because that's the first one you're exposed to back in 8th grade. And let's see, and the unique line postulate, which we will talk about that also later on, but it basically says there is but 2 points, through any 2 points there exists only one line. But as we work with this, we want to be able to write these equations in a line parallel to a given line that goes through a particular point. So write the equation of a line parallel to a given line that goes through a particular point, and then write the equation of a line perpendicular to a given line or segment that goes through a particular point. So we are going to be trying to write equations of lines that go through points that we are picking that are perpendicular and parallel to other lines that we are using. So as we go through that, just remember that we're going to be talking about some of those characteristics of parallel lines. Slope is the same, perpendicular lines. The slopes are negative reciprocals. As we talk about slope, and since we're going to be talking about parallel and perpendicular lines, we do want to recall that the slope of parallel lines will be the same, and the slope of perpendicular lines will be the negative inverse and negative reciprocal, and we will be looking at these. So if I put on here that, again, the slope is equal to m. It is also called the rise over run because that is our vertical change with our horizontal change. And then this is the delta y over delta x, which stands for the change in y over the change in x. And then we also should know the formula y2 minus y1 over x2 minus x1. So those are just some things that we should know at this point in time. And if we look here, as we go through this red line and look at this red line, I hope that you're able to identify its slope. And if we go from one point to the next, if I start off here at this point right here, and it is going to be, if I start off at 2, 3, and I go to the next point, I am going to go up 1, and I am going to go right 2. So my slope is going to be my rise over run. So I rise over run, I went up 1, which was a positive 1, and I went right 2, which is a positive 2. So my slope is going to be equal to 1/2. If I turn around and look at the yellow line is, let's see, if I start here at negative 1 and 3, and I go up 1, and then I go over 2, so it looks like, again, my rise over my run is going to be up 1 over 2, which is going to be my slope. So by definition, the red and the yellow line are going to be parallel. And then if I look at the green line is going down 2 over 1, down 2 over 1. So it looks like its rise over run is actually, it's going downward, which is going to be negative 2 over a positive 1. So the slope is negative 2 over 1. And if I look, this is a negative reciprocal to this. So that means that this line is going to be parallel. And I can go ahead and put in my little parallel markings. That line is going to be parallel to that line, and thus if it is parallel to one of them, it is perpendicular to that line, and if it is perpendicular to one of them, it is perpendicular to both since they are parallel. So that is calculating my slope. Now, using this unique line postulate, through any 2 points there exists only one line, what we're going to be doing here is we're going to be looking for the information that we need to create the equation of a line in both point slope and slope intercept. So if I put here the point slope form again is y minus y1 equals m times x minus x1, and that is the y minus is going to be part of the formula. Y1 will be an ordered pair, so we will need an ordered pair, x1 and y1, and we will also need to find out what my slope is in order to create this equation of a line. And in point slope or slope intercept, we will need y, it is y equals mx plus b, and where we need to know the slope, what that equals, and then b is going to be my y-intercept, so it is going to be x is 0 with some value of y. That will be where it crosses over the y-axis. So if I pick 2 points, so picking 2 points, points 5, 3, and 8, 10, I'm going to use those to come up with the point slope form of a line. And so starting off here, I have y minus, and it's going to be some value of y equals the slope, and then x minus is going to equal the value of x. So I can actually use either one of these points in which to fill in here. So I'm going to go ahead and use this, use the first point. So my x value is going to be 5, so that is going to go right there. And then my y value is going to be 3, and it is going to go right here. And the only thing I'm missing is slope, and I want to go ahead and just calculate my slope. Slope is going to be equal to y2 minus y1 over x2 minus x1, and I'll just call this, this will be 0.1, and this will be 0.2. So y2 is going to be 10. That will be minus y1 is 3. And then x2 will be 8 minus y, or x1, and that is 5. So I'm going to end up with, right there, I'm going to end up with 7 divided by 3. 10 minus 3 is 7. 8 minus 5 is 3. So my 7/3 is going to be m. So I can just go ahead and write that in here. 7/3. That's my slope. So that is the equation of a line. So if I rewrite it without my parentheses, I'm going to have y minus 3 is equal to 7/3 times x minus 5. There you go. There's my equation of a line. Now, if I want to use slope-intercept form, I'm going to go ahead and say, well, my slope, we've already calculated my slope, so I know my equation over here should be y equals 7/3 x plus b. Now, we don't know what b is yet. B, when x is 0, y is b. That would be the point we're looking for. So what we can do in order to calculate, we have 3 variables here. I have a y, an x, and a b. But I can go ahead and substitute either one of these x and y's in order to figure out what my missing b is. So I'm going to go ahead and use this first point again. And if I substitute in y is 3. And then I have 7/3 times my x, and x is 5. And that is going to be plus b. So I end up having 3 is equal to 35 over 3 plus b. I'm going to subtract 35/3 from both sides because I'm not afraid of a fraction. And then b is going to be equal to 3 minus 35/3, which b then is going to be equal to, I think that's 2 32nd thirds, which is improper. So let's see, what should that be? Goodness. This is actually 10 2/3, so that should be 12 2/3, I believe. B is 12 2/3, so I can go ahead and substitute that back in right over here. And I'm about to check my work, and let's see if I'm right. Hate it when I'm wrong. But let's see here, so that would be 12 and 2/3. That doesn't necessarily look like what I have over here. So why don't I go ahead and multiply it out and let's see. So I'm going to have y minus 3 is equal to 7/3 x minus 35/3. What I did here was I used the distributive property. And now I'm going to combine like terms. So I'm going to go ahead and add 3 to both sides. That is going to be y then is equal to 7/3 x. Look at this. I have 3 minus 35/3. Here I had 3 minus 35/3. So it looks like it's going to come out to be the same thing. It is going to be goodness. I did mess up on that previous problem, so I'm going to have plus 3 minus 35/3, and that's what I get for trying to do it in my head. So this is going to be 7/3 x plus 105/3, because I don't know what I'm doing. My apologies, not 105/3. How about it's just going to be 9/3 minus 35/3, which is going to be the same thing as minus minus 26/3. So let's see here. Let's see if I'm right, because I need to come back over here to this other problem and fix this. This whole thing right here, this whole thing is just wrong. I don't know what I was doing. So again, I have 3. That is going to be 9/3 minus 35/3. Which is going to give me a negative 26/3. And now looks like our numbers are going to be the same. So come up here and fix my equation. And sure enough, it's going to be negative 26/3. So both of those lines turned out to be the same thing. Just a matter of what form it was going to be placed in. And had you chosen to, you could have used this point and it would have come out the same, because that unique line passes through both of those points. So writing equations of parallel lines from an equation. Okay, so it says, reads, what is the equation in point-slope form of a line that is parallel to the given line and passes through negative 3.1? Okay, so if we remember, point-slope form is y minus y1 equals m times x minus x1. And I will tell you that we already have a x1 and a y1. So I can go ahead and write those in. I have y minus 1 equals my slope and x minus x1, which is negative 3. Now I need to figure out what my slope is. So if I look here, I do have 2 points in which to calculate my slope, and we'll just call this, point 1, point 2. And when I go to calculate it, I'm looking at m is going to be equal to y2 minus y1 over x2 minus x1, which is y2 is going to be negative 4 minus 2 over negative 2 minus 2. So that's going to be negative 6 over negative 4, which is going to give me 3/2. So my slope is equal to 3/2. So I would have 3/2 slope. Go ahead and write everything out here. Simplify, lose my parentheses, and I have y minus 1 is equal to 3/2 times x plus 3, because negative times a negative is going to give me the positive. So there it is in point-slope form. Now, write the equation of a perpendicular line. Well, if we were to, let's see, if we try to graph that line that we just drew, it is going to go through point negative 3, 1, and we have a slope of 3 over 2, which is going to be up 3 over 2, down 3, back 2, so this right there, okay? Now, if we wanted to go ahead and do the same thing, but let's make the line perpendicular using the same values, and the point is going to be negative 3, 1. And we want to pass it through there, and we want it perpendicular. Well, remember, my perpendicular slopes are going to be the opposite inverse, or the negative, not inverse, how about the negative reciprocal? So if my slope is equal to 3/2, then my negative reciprocal, my perpendicular slope is going to be equal to negative 2/3. So now I go to write my equation. I have y minus y1 is equal to my slope times x minus x1. So I have y minus 1, right, because there's y. And then my slope is going to be negative 2/3 x minus, it's going to be negative 3, sorry, which is going to end up becoming a positive. So I have y minus 1 is equal to negative 2/3 x plus 3. There you go. And there is my perpendicular line. And if I go and I go to graph that, I'm looking at negative 2/3, so 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, and there we go. There is my perpendicular equation of a line passing through point negative 3, 1. And now here where we get a little bit more challenging is when we write an equation of a perpendicular bisector. Now you got to remember that a perpendicular bisector, when it passes through, say this is point A, point B, and point C, well, that perpendicular bisector, line M bisects AB at C. That means that this segment is going to be equal to this segment. So we are going to have to calculate the midpoint when we are doing this. And in order to calculate the midpoint, you need to make sure you remember the formula. So remember that your midpoint is going to be your x values added together divided by 2, and then your y is going to be your y values added together divided by 2. And as we look at that, we'll go ahead and do a little example here. So we want to write the equation of the perpendicular bisector of the given line segment. So here's my given line segment over here on the graph, right? So I'm going to be going from negative 5, negative 3 to 3, negative 1, and then my midpoint is already been calculated for me at negative 1, negative 2, and I just want to draw a perpendicular bisector given that segment, and in doing so, we didn't have to figure it out, which seems sort of lazy on our behalf, but I know that we're going to go with slope-intercept form. So remember, my slope-intercept form is going to be y equals mx plus b. Okay. And let's go ahead and calculate our midpoint. Oh, I'm sorry, we know our midpoint, negative 1, negative 2. So I know the point that I'm going to be using is going to be negative 1, negative 2. I haven't figured out my slope yet, but my slope could be rise over run. So if I just look at my graph, I could say, well, if I start here, I go up 1, and I go right 1, 2, 3, 4. So it looks like my slopes rise over run. Rise over run is up 1 over 4, or my m slope equals 1/4. So I can go ahead and substitute that in there for m, 1/4 x plus b. Now I don't know, looking at this graph, what my y-intercept is because it's a fraction. I'm going to take a wild guess. I'm going to tell you it is negative 1 3/4, but we'll come back to that. We'll just see if I'm right. But let's go ahead and plug in some points, and I know that any of the points on the line should work. So if I'm going to go ahead and use the point that we are working with, and I'm going to substitute in the -1, -2 for my x and my y. So I have the y is going to be -2. That is going to equal 1/4 times my x, which is -1, and plus b to calculate my y-intercept. So I'm going to have -2 is going to be equal to -1/4 plus b. I am going to go ahead and add 1/4 to both sides, and that is going to be -1 3/4 equals b. Sure enough, look at that, bam, -1 3/4. So we're going to have y equals 1/4 x minus, I don't want to use that. I'm going to go ahead and use an improper fraction, and I'm going to convert that to 7/4. So y equals 1/4 x minus 7/4. There we go. And that is calculating that equation of a bisector. And just remembering, writing these equations are, sometimes one is easier to work with than the other, be it point slope or slope intercept, and that we are able to write these equations of parallel and perpendicular lines which are passing to a specific point. And for parallel lines, the slopes will be equal. For perpendicular lines, the slopes will be negative reciprocals. And use the slope and a point to write the equation in point-slope form, or you can use the y-intercept and write the equation in slope-intercept form. So whichever one is going to be the easiest for you to work with at the time. Either form is going to give you the same equation. It's just a matter that it looks different, but it's the same line.